great. So we have angles. An angle is made up of two rays that share a common endpoint. The computer's going to catch up here. So I can have ray AB and ray AC, and since they have the common endpoint of point A, then they create an angle. Now, in order to name that angle, so the sides of the angles are ray AB and ray AC. A is called the vertex, so that common endpoint is called the vertex. That's point A. And the names of that angle, there's different ways to do it. Sometimes we can just say angle A. Kind of looks like a is less than symbol, but it's not quite the same shape. Or we name it angle BAC, or we name it angle CAB. Sometimes we have to use 3 letters if there's more than one angle with vertex A. The A must be in the middle. The vertex has to be the middle letter when you're doing that. That must be the vertex. Okay? Angle BCA is not correct. We got some stuff going on there. So we have different types of angles. A straight angle is really a line. Okay? If I use those same letters, seems like a silly sort of a thing. A right angle is exactly 90 degrees. Its measure is exactly 90 degrees and would look more like that. Okay, and usually then you'll see a little box in the corner indicating it's exactly 90 degrees. An acute angle is going to have a measure less than 90 degrees. There's my is less than 90 degree measure. And so when you have one of those, it's going to be a small angle. An obtuse angle has a measure that is greater than 90 degrees and less than 180, but so an obtuse angle would possibly look more like that. So acute, obtuse, and right. So that's some vocabulary words that you need to know there about angles. Now we have pairs of angles that have special relationships to each other. If they are adjacent, adjacent means next to each other, side by side. Adjacent angles share a side. So adjacent angles share a side. An example of some adjacent angles, something like this. We'll go A, C, and B. We would say angle ABB and angle BBC are adjacent angles. They share side DB, ray DB as a side. So complementary angles are angles whose measures add up to 90. Okay. Now, they may or may not be adjacent. If you have a right angle and a ray in there, those are going to be complementary. Okay, it's angle addition, just like segment addition. Piece plus piece equals whole thing. The two pieces add up to 90. They don't have to be in that position to be complementary. Now, if this is a 30 degree angle, and this is it's probably a little too big, and somewhere over here we have a 60 degree angle, these two angles are going to be complementary because their measures add up to 90. And similarly, supplementary angles, their measures add up to 180. Again, it might be a straight angle, a linear pair, we call that. Those are going to be supplementary because a straight line has 180 degrees. They don't have to be. You can have some random angle here. Maybe this is about a 150. And then somewhere else you've got a 30-degree angle. Well, because their measures add up to 180, they're going to be supplementary. Okay, but it's two angles that add up, whose measures add up to 180. Okay, so this is just reiterating some examples here. How do you name, name the two rays that form the angle. The rays are, it has to start with the endpoint. A is the fixed endpoint, and AB. The vertex is the point in the corner. That's a point, so it's just capital letter A. We could either call it angle, BAB. We could call it angle, BAB. Since there is no other angle in that picture with A for a vertex, we can just call it angle A. Okay, so any of those is okay. Okay. Looking at this next diagram, name all of the angles that have B for a vertex. Now, because there's so much going on in this picture, sometimes what you will see, these little numbers here, that's to help name this angle. Like angle 5 is the same as angle GBE. It's the same as angle GBF, GBF. GBE. Those are all the same. Okay, so the 5, putting the 5 in there just helps us to not have to use all those letters all the time. So just be a little bit careful. So if B is our vertex here, so angle 5 has B for a vertex. Angle 6 has B for a vertex. Angle 7 has B for vertex. That's this angle. There's 5. It's angle 6. Angle 7, but then there's another one up here, and we're not even going to count the straight angles. Now, since they didn't give us a number on that one, we don't get to add them ourselves most of the time, but we can call it either angle. We can't just say angle B because there's lots of angles with that for a vertex. We can say angle ABG or GBA as long as the B is in the middle. B must be in the middle. Okay. Next question asks us to name the sides of angle 5. Well, angle 5, because that is here. It goes on, so I highlighted blue at the moment. So the sides are the rays, BG, and now notice it starts at B, it goes through E and F. You can call it BE or you can call it BF, you don't need both. It continues on forever further, so both are, either way to name that is fine. Okay. Part C. Name angle 6. Another way. B is the vertex, which means the B has to be in the middle. So either angle D, B, E, or D, B, F, either one. Don't need both, one or the other. Okay. So just be careful in notation and naming them. So I alluded to this a little bit before. Angle addition postulate. It's just piece plus piece equals whole thing. Okay. And if I'll try to simplify it a little bit here with, we'll call this angle 1, angle 2, and then the whole thing. I'm going to use different letters here. Oh, I don't really need that one. No. The measure of angle 1. So now when we're talking about measure, you'll see that little M with the angle measure there. Plus the measure of angle 2 equals the measure of angle LMO. Okay, so we're talking about the measures now. We need the little m. So this is really just piece plus piece equals whole thing for angles instead of for segments that we did before. Piece plus piece equals whole thing. And it's always about the measures. Okay, and we got a little bit here. Use the angle addition postulate to find the unknown. Don't go by looks. These are not going to be drawn to scale. Okay, what's the measure of angle KLH? My computer's gotta wait for my computer to catch up to us here a little bit, I guess. And it should just be KLH is the whole thing. So piece plus piece equals whole thing. 65 plus 25 is 90. That diagram is not drawn to scale. Okay, don't be, sometimes you have to get over the fact that things are not drawn the way they ought to be, but you just go with it. Okay, now, because we have one little arc here, one little arc here, that means those two angles have the same measure. So if this piece is 40, this piece must also be 40. So then angle BOG, the whole thing, is the 40 plus the 40, or 80. So you have to look for the markings sometimes. If they're not indicated, that just because they look like they might possibly sort of be the same, you can't assume that. You need to either be told in the directions or with labels such as those. Find the measure of each angle here. So angle POQ. POQ, that's this one here. That's 3x plus 3. Angle QOR is this angle. That's the 6x plus 4. And then we've got angle POR, which is the whole thing. POR is this whole thing, 15x minus 5. So again, using algebra now, so then piece, red piece, plus the blue piece equals the whole thing. And now we have to use our algebra skills. Combine like terms over here. I personally am going to subtract 9x from both sides. I just as soon keep my x coefficient positive. I'm going to add 5 to both sides. And then I'm going to divide by 6. Now, it does say find the measure of each angle. So we need to plug that back in to each of these angles. The measure of angle POQ is going to be 3 times 2 plus 3, 6 plus 3. This diagram is not drawn to scale either. QOR, 6 times 2 plus 4, excuse me, and POR, 15 times 2, 30, minus 5, 25. Notice 9 plus 16. Excuse me. About to sneeze. Okay. Now, they talk here real quickly here about opposite rays. Opposite rays form a straight line, which would be 180 degrees. So, now they also tell us that ray, these little arrows are super tiny, Kn bisects LKM. So, ray NK bisects angle LKM. That means bisects means cuts in half. Exactly. Those two have to be the same size. Okay? And then we know we have opposite rays. Now these are two different problems. We have LKM. That's the whole red one. The whole big red one. This is 7x minus 5. NKM is one of those pieces. How big is LKM? Okay, this is a 3x plus 9. Well, if that's a 3x plus 9, then this would have to be a 3x plus 9. No. So, two of those, add those together, 6x plus 18 would have to equal the 7x minus 5. Subtract 6x from both sides, and 23 equals x. Plug it back in to answer the question. 7 times 23, 140. 40, 161.